Our topic for today is circumference of circles. Now, the word circumference is just a specialized word that we use with regard to circles that just talks about the perimeter of a circle. So the distance around a circle is called the circumference. It's just another word for perimeter, but specifically related to circles. Now, there are a couple of parts of the circles that we need to remember, probably already remember, but we'll go over those again. If we start in the center of a circle and we go out to the edge, that distance is called the radius. And if we go from one edge of the circle through the center in a straight line right over to the other side, that distance is called the diameter. The diameter is always equal to twice the radius. So as you can see, this from here to here is a radius, this from here to here is a radius. You put those two together and you get a diameter. Now for centuries, since ancient times, one of the questions that's troubled mathematicians is the relationship between the diameter of a circle and the circumference of a circle. What we discover if we evaluate these or examine these or investigate these is that there's always the same relationship between the diameter of a circle and the circumference of that circle, regardless of the size of the circle. Whether you're talking about a paper plate or the circumference of the earth or any other circle that you can think of, take a marble and the difference between the relationship between the diameter and the circumference, it's always the same number. And so that number has been defined as pi. The number is called pi. And we abbreviate it, or we show it, with a Greek letter, the Greek letter pi, which looks like this. And that is just a number. Now, it's an irrational number. It's a decimal number that never terminates or never repeats. If you go on the internet, you would discover that there are places where pi is listed out to thousands of decimal places. There are competitions about who can recite the most places of pi. If you pull out your calculator and say pi equals, it'll give you 7 decimal places or whatever, depending on what you have. For our purposes, you'll never really need to know, it's not exactly equal to, but it's approximately equal to 3.14159. That is pi to 5 decimal places. Most of the time we only use 2. We would just say it's approximately equal to 3.14, or that it's approximately equal to, as a fraction, we sometimes use 22 over 7 as a fraction. That's roughly the same number. They're not all exactly right, but they're close enough for our purposes. So if you take the diameter of any circle and you multiply it by pi, then you're going to get the circumference of that circle. So another way to put this is that the circumference of a circle is equal to 2 times pi times the radius, or 2 times the diameter. This is the one we keep in mind, 2 times pi times radius, because we're often given the radius rather than the diameter. So for example, this circle right here, if we wanted to come up with the circumference of that circle, we would say C equals 2 times pi times the radius, which is 3.5 meters. And we can put that into our calculator, and you'll get a large decimal number. But if we put that in, we're going to get roughly 21.99. 2 decimal places, that's what we would get. You can put that in your calculator and check it. This example, now in this example, we're given the diameter, which means that if the diameter is equal to 4, then the radius is equal to half of that, which is 2. So if we use our formula, it's always a good idea to rewrite your formula so that it helps you remember it by writing it down a few times. And we have this circle, and we get the circumference is equal to 2 times pi times our radius of 2. And if we put that into our calculator and round it to 2 decimal places, we get 12.57 centimeters. Now, Sometimes you don't have a calculator. There are other reasons why you wouldn't use a calculator in some circumstances, or maybe you just want a quick answer. So what we can do in that situation is we can use one of our approximations for pi. So we'll use this one as an example. We're going to say again our circumference is equal to 2 times pi times the radius. And in this situation we have 2 times, remember we have the diameter, not the radius, so if the diameter is equal to 10, and the radius is equal to 1/2 of that, which is 5. So we get 2 times pi times the radius. And we know, because we don't have a calculator with us, we know that the radius is, that pi is about equal to 3.14. So 2 times 3.14 times the radius, times, we know the radius is 5. Now because of the commutative law, we can do these in any order that we want. So we're going to say 2 times 5 is 10, because that's easy to multiply by 3.14. 10 times 3.14 is 31.4 meters. Okay, easy enough to do without a calculator. Some other problems you can also do without a calculator. Let's say, for example, this problem over here, which gives us a radius of 14 centimeters. So we're going to do our problem again. C equals 2 pi r, which in this case means that we have 2 times pi times the radius, which is 14. And we're going to put in this situation, we're going to use 22 over 7. You'll see why in just a second. So we use the 22 over 7, 2 times 22 over 7 times 14. Now if you'll remember from the way we do multiplication of fractions, we can cancel. So what we're going to do is we're going to cancel, this is the same as 14 over 1, 2 over 1, we're going to cancel that 7, and we're going to cancel it and make it 1, cancel this 14 and make it 2. And then all we have to do is multiply across the top and across the bottom. We have 2 times 22 is 44, times 2 is 88, and it's just over 1, so we have 88 centimeters. And that is the circumference of circles.